today to interview one of our award winners, Christopher Schilling, CEO of Genomatica.
Oh, sorry. I didn't know she was a little too bright in here. It's a pleasure to be here, though, Nadia.
And we want to know about your company. Could you give us a little bit of an overview?
I'd love to. Genomatica is the leader in bioengineering. We combine bioprocesses and microorganism design with production economics and technology transfer to give bio-based processes to provide our partners with more sustainable everyday products.
Could you tell us a little bit about one innovative process that your company is working on currently?
Now, one of my personal favorite innovative processes is the metabolic engineering of E. coli for direct production of 1,4-butanediol.
What key parameters differentiate your process from the existing one?
Of course, Rosa. Now, oil and gas are used as the primary raw materials for manufacturing an array of large volume chemicals, polymers, and other products. Growing concerns over the environment have inspired a quest to develop a more sustainable process that afford these same products and renewable feedstocks with lower greenhouse gas emissions.
I just wonder how it's done. Could you describe the scientific basis for this innovative process?
In a recently published paper, we report what are, to our knowledge, the first direct biocatalytic routes to BDO from renewable carbohydrate feedstocks, leading to a strain of E. coli capable of producing 18 grams per liter of this highly reduced, non-natural chemical.
This sounds kind of reminiscent of the process for PDO. Could you elaborate on that a little bit?
We used a similar process to that to synthesize 1,3-propanediol, PDO, by introducing a 4-step pathway consisting of genes from PDO synthesizing bacterial species together with targeted changes to the host's central metabolism.
All right, Sam, could you tell me a little bit about the competitive landscape of your company?
Of course. So, being unable to compete with the highly established chemical companies, we decided instead to work with them. We sell them the technology that they need in order to run their plants in a more eco-friendly manner. Our competitors in the chemistry industry have such trouble with their annoying byproducts. But when we make the same materials, like caprolactam, we don't make excess amounts of ammonium sulfate.
Where do you foresee that your company has the biggest leg up on these purely chemical-oriented plants?
We are the perfect fit for countries where plants need to be built and operate within the market that they serve. Chemical plants transport their product. We, however, have a much smaller capex, which makes it economical for us to build on a modest scale.
That is incredibly astute of you. Now, what final takeaway would you like our viewers to have about Genomatica's competitive landscape?
So if you only remember 2 words about Genomatica, make it these 2. Feedstock diversification. Let's cut that up into bite-sized pieces for you. If you buy from us, we can offer you smooth sailing.
Thank you, Sarah. And now for a commercial break. We are here in the studio with Christoph Schilling, the CEO of Genomatica. Now, where did you get all of these great ideas for such an interesting approach?
So we used a pathway identification algorithm called Symphony Biopathway Predictor to elucidate all potential pathways from E. coli central metabolites to BDO.
Could you maybe draw a process flow diagram of this winning process on this whiteboard that's conveniently right behind you?
Of course, Rosa.
Now, while Christoph draws this PFD, I'm going to introduce our show's chemistry specialist, Nadia, to the stage.
First, we prepare sugar to make it ready for processing. Separately, we put E. coli into a reactor and add genes that alter its metabolism. Then we combine the E. coli and a prepared sugar in a fermenter, a unit operation that will be elaborated on later. After the fermentation occurs, we get a product stream containing E. coli, sugar, our desired butanediol, BDO, but with some potentially toxic byproducts, PTBs. We do cell removal to get rid of the leftover E. coli from our stream, then a sugar removal to get rid of the leftover sugars. We will also perform an evaporation to eliminate any extraneous water, and then a filtration to remove the PTBs, which gives us a final clean stream of BDO.
Now, could you answer for us the question that all of our audience members are dying to ask? What is your favorite unit operation?
Now, I would have to say the fermentation step, in which we use E. coli to reduce the highly oxidized starting material, carbohydrates.
That sounds like quite a complex process. What problems did you run into in this fermentation step?
As these compounds tend to be highly reduced, not produced biologically in nature, they are often toxic in the cell. The challenges met here are likely to be characteristic of the production of any commodity chemical biologically.
Thank you for an incredible interview.
Now, thank you, Rosa.
I'm here with our chemistry expert, Sam, to explain the fermentation unit operation in our process of making BDOs.
The fermentation unit operation is a bioprocess for a commodity chemical that is not naturally produced. Our engineered E. coli generates specific catalysts during the oxidative tricarboxylic acid cycle shown on the screen, which generates the reducing power to drive the BDO pathway. Thanks to this unit operation, we can produce BDO from any biomass-derived mixed sugar stream. In the reaction scheme shown, steps 2 and 7 occur in E. coli naturally, and all other steps, highlighted in red, only occur thanks to Genomatica's metabolic engineering.